Okay, we're taking a quick look at Nanobrain by Anirban Bandyopadhyay. Hello, Anirban. Making an artificial brain is not part of artificial intelligence. It will be a revolutionary journey of mankind exploring a science where one cannot write an equation. A material will vibrate like geometric shape, and then those shapes will change to make those changes will change to make decisions. Geometry of silence plays like a musical instrument to mimic a human brain. Our thoughts, imagination, everything would be a 3D shape playing as music. Composing music would be the brain's singular job. Anyway, I won't read it all. We're going to thumb through it backwards. Here's the bibliography. It's huge. So it's essentially a textbook. And then we start with the graphics in the back. Here, can you get this up here?
Yeah.
And you can see number of primes, human level, beautiful graphics, tables, an explicit kind of geometry. The reason I'm thumbing it from the back is so that we work towards kind of a random sense of what this book is about. 10 inventions awaiting commercialization. So at the end, you are discussing its application. So it's really a material science approach to artificial intelligence in which the thinking principles that govern thinking go so deep that you can actually create materials that will chart their own journey into intelligence. And Anirban, for those of you that don't know, Anirban is a pioneering physicist that works at the Materials Institute in Tsukuba in Japan, after contributing at MIT. This is really self-assembly of time crystals to a series of experiments that dislodged the neurocomputational doctrine, as it were. Beautiful graphics, Anirban. Yeah. Artificial brain. Not just artificial intelligence, but the artificial brain. And so it's based on this principle. My understanding from having heard some of Anirban's lectures, few of which I've actually understood, but my sense of it, having just bugged him enough to sort of get a sense of it, is that you have these nested sort of harmonic resonant sort of cavities, and the relationship of these resonances, which traverse scale, produce this sense of reality, I guess, that is the picture that we're seeing, that exists in these gaps between these nested cavities of resonance. So I don't know if I'm saying that correctly or not, but here is the language for it. He calls it time crystals. And we're looking at a very rigorous scientific approach to the problem. And over here we have a crystalline structure that we've seen this in action. This is actually a series of electrodes that he's put together, and it demonstrates an information processing topology. So as we weave towards the front of the book, we get more into the elements of the science that was validated in research. That this is beautiful right here. This depicts how at the tubulin level you have a fundamental structure in which all the different frequencies are sort of consolidated. They congregate there. Lovely. Oh, and look at this. Inductor. Anirban, very clever. Not memristor. Oh my gosh. Oh, and here we go. This is the fusion of gardens, you call it, I see. Meander flower garden. And here are the crystals taking place at varying scales And here we're connecting it with the neuroscience, the cerebellum, the thalamus. All right. And how the topology comes together. Beautiful. Oh, look at that. Time crystal of the human brain. That is gorgeous.
Sorry.
Penny's not listening. But she says hi, Anirban.
Hello.
And Amatista is holding the camera. Oh, wow. This is awesome. I've been waiting for this.
Even though
Water
I don't
crystal,
understand a word.
tubulin cylinder. But you can explain everything when we see you in 30 seconds, right? We want the 30-second explanation. It's beautiful, Anirban. We're so happy for you, man. Wow. So a little light summer reading. Wow, and then here we incorporate primes, our understanding of primes, primes in proteins, primes in DNA. Wow. There is no terrain that Anirban will not traverse to understand artificial brains. All right. And now we're starting to understand neurons in the context of this geometric time cycle. And this was some of the images from the presentation that you did at Science of Consciousness conferences that shows how you have these oscillations at different scales, terahertz, gigahertz, megahertz, converging to create this reality that we are enjoying. The picture of the frog coming together, as I recall, in the gaps between the resonance. Wow, these are stunning graphics. And this book is only 130 bucks. It's a first edition. It's going to be historic. This might be as historic as Einstein's 4 papers. All right. Excellent. Unprecedented technologies. The limited fractal machine. Why we can predict the future. All right, the psi effect.
There he is.
Information entropy. Hold on a second. Hardware architecture of the artificial brain. How are we doing, Amatista? Almost there. Time crystal grows by itself. This is what's so fascinating. I was trying to tell my students about this, Anirban, and they started referring to the idea of something that grows by itself as the blob. The artificial intelligence blob. All right. The mathematics. Okay. This is going to be a tour de force of the mathematics governing resonance across scale. Jesus. All right, so there we have it. And as we get to the early chapters, we are looking at the foundations of these ideas. Well, I think it came together in a lovely way, and I'm so excited to read it. And I will be hanging on every other word, I guess, if not all of them. So thank you so much. Well done.